we are here to begin with our topic of discussion, that is fermented Oriental products. Before we venture into the products, let us first briefly go through the fermented foods. There are so many foods available which are fermented in nature. That means to say they are produced by some microorganisms incorporated into them to give a sound product which has generally a longer shelf life. They do also have some better taste and nutritive value. Meaning with the Orient generally implies the East, and the Oriental products are present in the China, Japan, Hong Kong and the nearby areas. The first product that we are going to discuss is miso. It is a similar product like the soy sauce. The only difference is in soy sauce the product is liquid, while this particular one is a paste-like component. We can see here the paste of miso, which is very often used as a condiment or a seasoning in most soups in the Chinese or the Oriental region. Miso actually originated in Japan in the Jomon period, and first it was produced in those areas. 3 types of miso are available and they differ depending on the starting material used. Obviously, if the starting material differs slightly, the organisms that are producing will also differ. Accordingly, the 3 varieties are based mainly on the color. The first one is a white miso, while the second one a red variety. The third one is a mixture. The first is called by the name Shiro miso, while the second one aka miso, while the mixed variety is called as avis miso. These are all available in the market as paste and can be preserved for a longer time. The ingredients that are used for the production of miso includes soybeans essentially, barley, rice. It can also include buckwheat, millet, rye, wheat or other seeds and cycads. We will be mainly discussing rice miso because that is the traditional Japanese product and commonly available all throughout Japan. The soybean seeds are the common ingredients, while barley can also be used along with rice. We can have a separate protocol which combines the soybeans and the rice and other product which will combine soybeans and barley. And not to forget the important mold Aspergillus oryzae, which is also used in the production of soy sauce, is used here for production of the koji, which will be required to inoculate the soybean and rice or soybean and barley mix to finally give us the miso. These are other organisms which get incorporated into the mixture to give us a sound product. Other organisms include Pediococcus, Saccharomyces, Torulopsis. These are yeasts, and we also are familiar with Streptococcus faecalis, the typical bacteria which is required in the production of miso. Let us briefly go through a flow chart to understand how miso gets produced. Polished rice is important. Japan uses the variety of polished rice. It gives the best miso. Unpolished rice can be used at times, but the product has different variety taste and it is not as par with the Japan variety. For making the koji, polished rice is used. What is done is, first the rice is soaked, then it is cooked and finally incubated with the koji mold. This is how we obtain the koji. Next, on the other side, we are preparing the soybean which will be fermented. The soybeans are usually whole soybean taken. They are again soaked approximately for 16 hours and then cooked, maybe steamed as well. Now these are mixed all together. So somewhat similar to what happens in soy sauce is done here, but after the mixture is added, brining or salt addition is often done, and this is the time when the yeasts already mentioned as Torulopsis and Pediococcus and the lactic acid bacteria Streptococcus faecalis are involved in fermenting the mixture into a product which is very much similar to soy sauce. Now in case of soy sauce, it is pressed to get the liquid out, While in case of miso, what we are doing is, after the fermentation, we are keeping it for aging. That is, can be kept for longer time to retain the organoleptic properties which will be made during and after the fermentation process. After that, the whole product is just mashed. Means we do not extract anything by pressing, but the whole structure is just mashed to give us a paste. This is how miso is produced. We can see here a production of barley miso, which includes the salt that is most often used is the sea salt and not the common salt, and barley grains and soybeans remain. Other than rice, we are introducing the barley grain here. The process followed is similar. A koji making process involves Aspergillus oryzae. The whole contents are mixed and allowed to ferment and kept for aging. So the process remains same. The product gets different tastes and flavor because the starting material varies. This is how we can generally use the miso paste, mainly with the soups. In Japan, this is a very common ingredient found in most households, and soup are seasoned with miso paste. Next, we are moving on to the second product, which is tempeh. Now, this also looks very much similar, but has a different texture. It is not exactly a paste, but a cake produced by fermentation of organisms on the soybeans again. The organism involved here is not Aspergillus, but here it is Rhizopus oryzae. The structure you can see is slightly different. It has a dome-like structure, Aspergillus having a typical spherical structure. So we can identify, and the strains that are used in the production of tempeh are obviously different from the ones used for the production of soy sauce and miso. This is a brief procedure of how tempeh can be produced. Since we are discussing all these products mainly of soybean fermentation, the mold variety remains almost the same with slight differences, and the processes are also pretty similar, like soaking of the soybeans, then treating them or cooking them, which can also involve steaming process. So these things are quite of similar, but the rest with the inoculation processes are slightly different. Here we begin with a dehulled full-fat soybean grits. Now this is very important to have full-fat soybean, that is beans from where fat has not been taken out or oil has not been extracted. Now these are mixed with tap water and soaked for at least 30 minutes at 25 degrees centigrade. Then the water is drained, and further cooking incorporates use of more water. Now when we drain the water that we have used earlier, it reduces the typical ammoniacal flavors or strong flavors associated with soybeans, which most of us dislike. In the next step, after the cooking, finally draining and cooling leads the soybeans to be inoculated by a spore suspension of the organism already mentioned, that is Rhizopus oligosporus or Rhizopus oryzae, as we can see here. Then they are finally packed. At times, if we are carrying it out in small scale, we can pack individually in petri dishes or most often in banana leaves. Now, the use of banana leaves in tempeh production generates another kind of flavor and allows the proper growth of the mycelium nature of the fungi that we have used here. The whole thing packed tightly are incubated at 31 degrees centigrade and can be kept for approximately a day to get what is known as the tempeh cake. Now, unlike soy sauce and the miso, which we generally use as a seasoning or a dip, here we can use the tempeh cake directly as food. It is nutritious and even filling. Here we have tried to show the trays in which the whole thing after mixing gets packed and can be at times covered with a lid to get a pressure so that the cake formation occurs. How does exactly the cake formation takes place? Now, because it is a mold, Rhizopus, it grows with lot of mycelium. So, it incorporates the soybean in the network or mesh of the mycelium, and finally, after the 1 day long fermentation stage, they generally hold all the soybean into a tight cake-like mass. This is how tempeh is getting produced. We move on to the third product, which is Sufu, and I think I'm very sure that most of us are very popular with the term Sufu. It is of Chinese origin and it is called by several names like either fermented tofu or sometimes tofu cheese, Chinese cheese. Several other names are given for Sufu. Again, a soybean product. It is a processed product and can be preserved for a long time. The organisms involved here for fermentation are Mucor or Mucor mucido, and along with this, Actinomycor elegans. Most often people say Actinomycor elegans is the choice organism for getting good kind of Sufu, while in the history or earlier days, the Sufu was prepared mainly from Mucor mucido. We are going to see the production of Sufu, which incorporates three stages. First, the production of tofu, then getting the fermentation stage, and finally brining. So, in the case of tofu production, we will first understand how to get the soy milk. Now, if we actually look here, whole soybeans are used, which are first soaked and then ground with water to get a paste. Then this slurry or the paste that is obtained is heated at approximately 95 to 100 degrees C and then kept for 3 to 5 minutes, after which the whole thing gets filtered. Then we take out the residue, the solid part that is there, and the milk is taken, which is called as soy milk. We can see here the production of soy milk. The straining part is going on over here to get the soy milk out, and the residue will be left on top of this cloth. Generally, cheese cloths are used to get the filtration process done easier. Going back into the flowchart again, we will see after we get the soy milk, we can get tofu from these, and generally two categories of tofu are produced. It can be either the simple regular tofu and the silken tofu. Now, when we want to get Sufu, we would like to have regular tofu and not the silken tofu. What we do here is generally soy milk with 5 to 6% solid are taken, and then whole thing is brought to around 75 degrees centigrade, that is by heating obviously, after which is the interesting step of coagulation brought about by the coagulant, which is calcium sulfate salt. Now, interesting to note, this has a similarity with cheese production, another fermented milk product often consumed in the European countries. Now, once the coagulant is added, this generally allows the coagulation of the milk that is taken. Once the coagulation takes place, what is formed is curd, which is taken and pressed into molds. After this, the whole thing gets cooled and it is cut in small cube size to get regular tofu. Silken tofu we are not discussing because it is for regular consumption, since our interest lies here in production of Sufu. So we take the regular tofu and get it for the production of Sufu. After the tofu is obtained, the organism Actinomycor elegans is introduced or cultured into these small cut pieces, and again salting is also done. Aging can be done at times, and here we can see how the growth of Actinomycor elegans takes place on tofu. I hope it is distinct and clear to see the pink coloration or white coloration overgrowth of the fungi, which is giving us a prepared Sufu product. Sufu are consumed in many Oriental countries and mostly for people who are having problem with lactose, are called as lactose intolerance. This is also a very much cheese-like product, can be consumed on a similar note but without the problem of lactose intolerance. Now, lactose intolerance basically refers to problem of people who cannot ingest lactose, which comes from milk. Soy milk does not have such lactose, and as such, it is safe for those people. Next, we are moving to another product called as Natto, a Japanese product, again beginning with soybeans. Now, fermentation here is brought about not by a mold, but interestingly by a bacteria by the name Bacillus natto. The species name is given because the product formed has its name natto. Now, the soybeans here are simply mixed with the culture. The culture of bacteria can be obtained from a normal culture collection center, or at times the places where they produce natto generally keep a culture of these bacteria. The product gets a sticky appearance. This is interesting because this kind of bacteria produces extracellular slime which binds the fermented soybeans together, and a mat-like structure or a kind of slime-like structure, as you can see here, gets produced within these. Now, why will people consume this? Now, this is interesting because only in places like Japan, they consume natto. In other places, they don't consume and do not like at all the musty nature and this slime-like nature of natto. While in Japan, it is very much enjoyed on rice, and at times, the natto can also be seasoned with soy sauce, salt, and even mustard. We come to almost the end of our product with Natto de coco. There are so many other products to discuss, but this particular one has an interesting effect. What is the ingredient used here? It is very interesting to note that coconut water is in use here to give us a product which is known as Natto de coco. Natto de coco can be used like whitish cubes, as you can see here, in fruit salads, and it will have the taste of coconut water. And how do we get it? The whole microbiology involved here is also very interesting. A typical bacteria by the name Acetobacter xylinum is involved here. This particular bacteria has the ability to produce cellulose called as microbial cellulose, and these generally incubated along with the coconut water binds the whole thing, giving it a paste or jelly-like property. Thus, it is very similar to the jelly cubes that you can normally use in any preparation like a fruit salad or so. So this is important. Why should anyway use a Natto de coco? This is a traditional product of the Orient, and people consume it because coconut is widely available and they can produce this product. It can be kept for a longer time because it is a fermented product, so it has several properties which will enhance the keeping quality rather than other kinds of jellies. So we have seen some of the fermented Oriental products like the Miso, Tempeh, Sufu, and so much. Now, if we want to discuss, there are so many more, we cannot end the list. There are the Chinese red rice called as Angkak. There are several fish paste and fish sauces. But we had a clear idea that molds, bacteria, and yeasts are involved in getting these fermented products. Now the big question is, why anybody would like to consume these fermented products when we can consume simple products from the substrates that these fermented products are produced? The only reason can be the people who consume definitely have attained certain benefits from these fermented products. Not to forget, there are several benefits of the fermented dairy products already in line, the probiotics that we come from the dairy products. But in the Oriental dishes, these fermentations have brought about a lot of change. The soybean, which is a bland and at times a strong flavored compound, can be slightly milder if a fermented product is obtained. That means people would enjoy the taste of a fermented product over the traditional substrate. Then there are other reasons, like most of the time the nutritional benefits are more in a fermented product. A fermented product can be kept for a longer time, that is, increases the preservation time. And not to mention, sometimes even there are other health benefits derived from many fermented food products. Now, there are problems of mycotoxins. Mycotoxins are toxins elaborated by molds, and since most of the Oriental products have molds during their fermentation stages, it is a clear-cut hazard at times. But a lot of research have shown that no mold which are used in the production of these Oriental fermented products produce mycotoxin. So we can be sure of a safe product while enjoying these fermented Oriental dishes. Can be prepared very easily at the home because in most of these places like Japan and China, they have homemade recipes of these products. So all of us can enjoy these Oriental dishes and let them not be in the Orient and can be used in many different places now.